Let theta be an angle between pi and 2 pi such that tan theta is equal to 12 on 5. Find the exact value of A, sine theta, B, sine 2 theta, and C, sine theta on 2. Well, first let's figure out where theta is. Here's the unit circle. There's the y-axis, there's the x-axis. And angles are measured anti-clockwise from the x-axis. So this would be pi, 180 degrees, and this would be 2 pi, just there, like that. So my angle is somewhere in here between pi and 2 pi. Okay, that's good. Now we do have a slightly more information. We know that tan theta is 12 on 5, which is positive. And we actually know where each of the sine, cos and tan are positive. All positive here, sine positive here, tan positive here, cos positive here. So if tan is positive here, and our value of tan is positive, it's 12 on 5, that means that tan is actually here in the third quadrant. So we should write that down. Theta is in the third quadrant, so is in from pi to 3 pi on 2. So it's in here. There's pi on 2, there's pi somewhere in here. We don't know where it is, but it's in that quadrant. We should give a reason. Since tan theta is positive. Alright, well we should be able to start figuring out where everything is. I knew if my angle fitted into a triangle, I could draw a right-angled triangle using the value of tan theta and figure out what sine theta and cos theta are directly from the triangle. Of course, my angle is a reflex angle, just here like that, so it's not going to fit in a triangle, but I do know that if I used an angle that would be in a triangle, an angle between 0 and pi on 2, then the values of sine and cos and tan would all be the same, except with possibly different plus or minus signs. So in order to cope with that, I'm going to make a new angle. Let theta be between 0 and pi on 2. Let theta, which is in the interval from 0 to pi on 2, have phi. Let phi, which is in the interval from 0 to pi on 2, have tan phi is equal to 12 on 5. And then phi certainly fits into a triangle. So consider the triangle shown. So if we draw this triangle, it'll be a right-angled triangle like that, and we'll put phi here. And tan phi is 12 on 5, so tan phi is opposite over adjacent, so that would be opposite would be 12 over adjacent would be 5. Now we can figure out the hypotenuse of this triangle by using Pythagoras' theorem. Hypotenuse is equal to the square root of 12 squared plus 5 squared, which is the square root of 144 plus 25, which is the square root of 169, which is 13. And so from this triangle I can tell that sine phi is equal to opposite over hypotenuse, so that would be opposite over hypotenuse, which would be 12 on 13. And while I'm at it, I might as well calculate what cos phi is. Cos phi would be adjacent over hypotenuse. So 5 on 13. Right, so now I know what sine and cos of phi are. Hopefully I'll be able to use those to figure out what sine and cos of theta is. So we do that by just figuring out where theta is, because the numbers will be the same. We'll just have possibly different plus or minus signs in front. Theta is here in this quadrant where only tan is positive. So we now are able to figure out what sine and cos of theta is by just making them negative, because sine and cos are negative in this quadrant. Therefore, sine theta is negative 12 on 13. And even though it didn't ask me, I might as well say what cos theta is. Cos theta is negative 5 on 13. Alright. So let's do part B now. Part B, I needed to figure out what sine of 2 theta is. Well, let's just think about where 2 theta is. If theta is between pi and 3 pi on 2, then 2 theta would be between 2 pi and 2 times 3 pi on 2. So 2 theta would be between 2 pi and 3 pi. So up here in these top two quadrants. And sine is positive there, so I know at least that my answer will be positive. But I still really don't know where it is. It could be anywhere in here. So what do? I know. I use a formula. This is 2 sine theta cos theta. And I know what sine theta and cos theta are. I've got them just up here on the board. 2 times minus 12 on 13 times minus 5 on 13. So multiplying the top, 2 times minus 12 times minus 5, the negatives will cancel, so I'll get a positive. 2 times 5 is 10, and 10 times 12 is 120. And the bottom will be 13 squared, which is 169. So that's my answer for sine 2 theta, which is positive, as I knew it would be because of where 2 theta is. Excellent. Let's do part C. So for part C, I needed to find sine of theta on 2. Well, I would use a formula, but I don't know a formula for sine theta on 2. But I do know that if I had sine 2 times theta on 2, then that would be 2 times sine theta on 2 cos theta on 2. Like that. Which would be good, because I need to know what sine theta on 2 is. I need to know what this is. And I know what this is because it's really just sine theta, so I know what that is. So I could rearrange it, only I need to know what cos theta on 2 is, and I don't. Well, I could possibly figure out what cos theta on 2 is using the double angle formula for cos. Let's try that instead. So the formula for cos 2 theta is cos squared theta minus sine squared theta. Okay, but again, I'm going to have a problem with the cos theta in the middle there, so what about cos 2 theta is equal to 1 minus 2 sine squared theta. That's one of the other options which I get by replacing the cos squared theta here by 1 minus sine squared theta. So I get 1 minus sine squared theta minus sine squared theta, which is 1 minus 2 sine squared theta. Let's use that one instead. And so cos 2 theta on 2 would be 1 minus sine 2 theta on 2. And now I know what cos 2 theta on 2 is. It's cos theta. So now I've got a formula involving cos theta and sine squared theta on 2. Excellent. So I can sub in the value of cos theta. It was minus 5 on 13. Oops, sorry, not 15 on 13. Minus 5 on 13 is equal to 1 minus 2 sine squared theta on 2. And I can subtract 1 from both sides, so that would be minus 5 on 13 minus 13 on 13, which would be minus 18 on 13 is equal to minus 2 sine squared theta on 2. And I can divide both sides by 2, so that would be minus 9 on 13 is equal to minus sine squared theta on 2. Oh, and I don't really need those minus signs, do I? I could just divide by minus 2, so that's good. And so starting a new page, I've got sine squared theta on 2 is equal to 9 on 13. So sine theta on 2 is equal to 3 on root 13, doing a square root of the top and the bottom. But I don't know whether it's plus or minus yet, and I'll need to figure out whether it's plus or minus based on where that angle is. So let's go back to the beginning and have a look. Well, if theta is in pi, between pi and 3 pi on 2, so in here, when I divide that angle in half, I'll get it between pi on 2 and 3 pi on 4. Let me write that down. So theta now. Theta is in pi to 3 pi on 2. So theta on 2 is in pi on 2 to 3 pi on 4. And 3 pi on 4 is still less than pi, i.e. theta on 2, or maybe not i.e. So theta on 2 is in the second quadrant. And in the second quadrant, sine is positive. So therefore sine theta on 2 is equal to plus 3 on root 13. And that's the end of the question.